Hello, Integrated Math 2 students. It's Mrs. Robinson back to Work Practice Benchmark Chapter 12 with you. This chapter is long. There were 12 sections. So this test is going to have 30 questions on it. It's a little long. If you need to do half of it and take a break and come back and do the other half, fine. Work it how you'd like to work it, okay? Let's go ahead and do number one. What are the coordinates of the vertex of the graph or table? Is it a maximum or minimum? So we're working with quadratics in this chapter. So there are parabolas. Let's go ahead and look at this parabola. We need the vertex. We're looking at the graph, and this should be pretty straightforward. Let me get my pen. Hold on. Okay, so go ahead and look at the vertex, which will be right here. And let's find the coordinates. We go over 0, up 1. So the vertex is 0, 1. And is it a max or a minimum? Well, it's the lowest point on the graph, so it's going to be a minimum. Anytime it opens up or it has a happy face, you have a minimum, and you're done. Let's go ahead and look at number 2. All right, graph this function and identify the domain and range. Y equals 0.5x squared, or 1/2 x squared, if you want to write it like that, okay? If you prefer to use it in fraction form. So we know when we're graphing, you can go ahead and graph using Desmos and a calculator to check yourself. But when we graph, we want to use the vertex as negative b over 2a for our x point, and then we plug that in to get our y point for the vertex. Then we can figure out the axis of symmetry, we can plug in other points to figure out how we're going to graph it, and our basic function looks like this for a quadratic. Y equals ax squared plus bx plus c. And we look at this, you can see all we have is this part. We don't have bx plus c. That's fine. That means my b value was 0 and my c value was 0 because they're not here. So if I want to find the vertex of this function, I can just go b is 0, so negative 0, which is 0, over 2, and then my a value is 1/2 or 0.5. So if we calculate this out, well, 0 divided by anything is just 0, so my vertex, my x value will be 0. Now I'd like to find my y value, so I take this and I plug it into my function. 0 squared is just 0 times 1/2 is 0, and I get out 0 for my y value. All right, so there's my vertex 0, 0. My axis of symmetry goes right through my vertex, so it's going to be x equals to 0. There's my axis of symmetry. Now I need to find a few points. This guy makes my graph either fatter or skinnier. Now if you know your basic y equals to x squared graph, you should know the basic graph. The a value tells you, this value tells you if you're positive or negative. It tells you if you open up or down. If it's positive, you open up. So my basic y equals to x squared graph looks something like a happy face parabola. Now how fat or how skinny do I make that? Well, it depends on this. So let's go ahead and just plot a few points to make sure we have this as accurate as possible. If I plug in 0 for x, we already know I got 0 for y. So let's plug in 1. If I plug in 1 for x, 1 squared is 1, and I take half of that, I'm going to get 0.5. Let's plug in 2. If I plug in 2, 2 squared is 4, and half of that's going to give me 2. Do it on the negative side, or you can just know you get the exact point on the opposite side. So let's go over 1, up 1/2. There's my first point. Over 2, up 2. And I do those exact same points on the opposite side. So I went over 1, up 1/2. I'm going to go back 1, up 1/2. And I'm going to go back 2, up 2. And you can go ahead and plug in -1, you're going to get 0.5. And -2, you're going to get 2. All right? Then kind of sketch that graph. And you can see how fat or skinny it is. Sorry, that's not very pretty. And there you go. All right, on to number 3. Let's pause it. All right, now talking about how wide or how slender we should make our graph, they want us to order this group of quadratics from widest, so how fat it is, to the narrowest. Now if you look, The A value tells you if you open up or down, and each one of these has an A value that is negative. It's negative here, negative here, negative here. So each of these graphs is going to open down. Now, how fat or skinny should I make it? Well, you can go ahead and just do an XY chart. You know you have your basic graph. You have this. Let's pull back to this. You have y equals ax squared. You're going to have 0, 0, and then this tells you how fat or skinny. We know these are all going to open down, so they're all going to be like this. How skinny or how fat should we make them? I don't know. You need to plot some points. Start with this graph and say, all right, we know 0, 0 will be for each of them, but start with 1. 1 squared is 1, and 1 times negative 2 is negative 2. And then that will be for this graph. Now look at this graph. Plug in 1 for this graph. 1 squared is 1. 1 times negative 5 gives you negative 5. So for this graph, I'm going to go, let's erase this. So let's go ahead and look at this graph. For this first graph, that's this one. We'll just do arrows so we know what we're talking about. And this is for this graph. We know we have 0, 0. They're going to open down. This one's going to go over 1, and it's going to go down 2. And I'm going to have that same point on the other side. This graph is going to go over 1. It's going to go down 5. 1, 2, 3, 4, 5. So it's going to go down a lot quicker. All right. So this first graph might go out a little more. The second graph's going to go straight down faster. All right. So looking at that already, I can tell that bigger number is going to make me go skinnier. So this one will probably be in between these two. Let's go ahead and look at Desmos real quick and just see what that would look like if I graph this. So if I open Desmos and clear this off, all right, clear, and I type these in. I believe they were y equals to negative 2x squared. There's your first graph. And your second graph would be, oops, I did a minus sign, y equals to your second graph. So there's your first graph. Let's move this down. Let's look at your second graph, y equals to negative 5x squared. There's your second graph, so it is skinnier. That's in blue. And the third graph was y equals to negative 4x squared. And that third graph is the green one, which is in between the blue and the red, just like we thought it would be. So let's go ahead and order these. So we want from widest to narrowest. And then going back here, we knew the red was our widest, so the negative 2x squared. So we're going to go, all right, from widest to narrowest, it would look like this. Y equals to negative 2x squared. Then y equals to negative 4x squared. And the narrowest will be y equals to negative 5x squared. And you're done. Okay, looking at this graph, how is this graph different from this graph? Well, later on in the chapter, you learn about vertex form. Let's just use what we know about our shifting of basic graphs. Anytime you have your basic graph, y equals to x squared. If you'd like to shift this, let's say hk is your new vertex. Your new vertex form would look like this. X minus h squared plus k. So this is always the opposite, and this is always straight up and down. Now looking at this, you would have an a value here too, and that's fine. Looking at this, there's nothing inside the parentheses that's getting squared. So I'm not shifting left or right. That's always your x value, shifting left or right. And it's always the opposite. When you shift graphs, it's the opposite on the inside, and then the outside is your up and down. And that is a direct shift. So if you look at this, how is this different from this? Well, they're the same exact graph, except for this one, I shift my k value down 1. So I'm going to shift down 1. So how is this graph different from this graph? It's this graph shifted down 1. Go ahead and graph both of these on Desmos and see what it looks like. All right, let's go ahead and Okay, number 5 asks us to graph the function, identify the vertex and axis of symmetry. So knowing your basic function is y equals to ax squared, that's supposed to be an x, plus bx, that's a plus c. There's our basic function, and we know the vertex is negative b over 2a, and then you plug that in, you find your y value. So let's do, our b will be 2, it's next to the x, so we're going to go negative 2 over 2 times our a value. Our a value is next to the x squared, so that will be 2 over our a values, nothing's written there, so it's a 1. All right, and negative 2 divided by 2 is going to be negative 1. There's the x value of our vertex. Now we need the y value. To get that, we plug in to our function for x, and we're going to get y equals 1 squared plus 2 times 1 plus 2. And I apologize, I meant to say negative 1 squared plus 2 times negative 1 plus 2. I'm plugging in negative 1. Sorry about that. All right, negative 1 squared is 1 plus 2 times negative 1 is negative 2 plus 2. Negative 2 plus 2 is 0, and then I'm going to just get out y equals to 1, and I'm finished. So negative 1, 1 is my vertex. Negative 1 up 1, there's my vertex. The axis of symmetry goes right through my vertex. Your axis of symmetry will always be x equals to the x value of your vertex, negative 1. There's my axis of symmetry, there's my vertex. I want to see both these points. Now pick a few more points, x, y points to graph. So we know negative 1, 1. Let's plug in 0. When we plug in 0, 0 squared is 0. 2 times 0 is 0. We just get out 2. Our c value is usually our y-intercept. So 0, 2, or it is our y-intercept, not usually. All right, let's plot that same point on the other side of the graph. So we went over 1, up 2. We go back 1 and up 2 because they're similar. You can plot one more point. Try 1. If I plug in 1 here, 1 squared is 1. And then 2 times 1 is 2. So I'm going to have 1 plus 2 plus 2. 2 plus 2 is 4, so I'm going to get out 5. I'm going to go over 1, up 1, 2, 3, 4, 5. And do the same on the other side. And there's your graph. And you know that you're graphing up because of the points you plotted and also because the a value is positive. Good. Let's go on to number 6. Okay, so number 6, what are the solutions of this equation? Use a graph of a related function. So what that means is we need to graph this and see where it crosses the x-axis. That's what we're going to look at. Solve this by graphing. All right, this is not in the form that we want. We want everything to be on one side of the equation. So let's move this over to here or this over to here. It doesn't matter. Let's go ahead and move this over. So we're going to go 4x squared and move the 4 over here by subtracting 4 from both sides. Minus 4 equals 0. If I subtract 4 to both sides, this becomes negative 4 and that becomes 0. So here's our function. We want to know where it's 0. We're going to set that equal to y or f of x. Okay, either way you want to look at it. So what we want to know is where y is 0. That's what we want to know. That's how we solve this by graphing. Where is y 0? That happens when I cross the x-axis. Because if I go over 1 up 0, I'm on the x-axis. If I go over 2 up 0, I'm on the x-axis. So I want to know where I cross the x-axis to figure out the solution to this equation. Because I want to know where y is 0. That's on the x-axis. So let's go ahead and graph this. 4x squared minus 4. If I graph this using the vertex method, this is going to be the a value. And there's no x, so there's no b value. So my a value is 4. There's no x term, so that means my b value is 0. And my c value is negative 4. And that's usually going to be my, well, it will be my y-intercept. So let's go ahead and do the vertex method. Negative b. So negative 0 over 2 times a, which is 4. Well, anytime you have 0 in the numerator, you just have 0. So I have 0 for the x value of my vertex. Now I plug it in here to get my y value. Well, 4 times 0 is 0. 0 minus 4 is negative 4. So here I have it. 0 down 1, 2, 3, 4. There is my vertex. Axis of symmetry goes straight through here. This is positive, so I'm going to open up. And I need to open up, right? Or I'm not even going to touch the x-axis, so that's good. Now just find some points on either side and see if we can hit the points where it crosses the axis. So I'm going to go over 1. I know what 0, 0 is. When I plug in 0, I get out -4. Let's see what happens when I plug in 1. When I plug in 1 here, 4 times 1 squared is 4, -4. Ooh, I get 0. There it is. If I go over 1, I get 0. That means the same thing happens on the other side. And there's my 2 solutions. I found them. I know I only have 2 solutions. I don't need to look for other solutions because this is a parabola and this tells me how many solutions I should have. 2. Okay? It's only going to go up once. It's not going to go up and come back down. All right? So I know my solutions are x equals to 1 and -1. And I'm done. Okay? Don't put that in parentheses. That's not an ordered pair. Okay, this one, the area of the playground is 75 square yards. The length of the playground is 3 times longer than its width. All right, so looking at a playground, you know the length is 3 times longer than its width. If you're a drawer and you like to draw things out, you can go ahead and do the length. If this is the width and this is the length, you know the length is 3 times the width. So you know the length is 3w and the width is here. Write the length in terms of the width. So for this part, I would say the length is 3 times the width. All right. Write an equation for the area in terms of the width only. So we know area is length times width. We want an equation, so this is for part 2. We want to create an equation in terms of the width only. I can't have 2 variables. So I know the length is 3w. So write it in terms of width only. I'm going to say for the length, I write 3w. And the width, I write w. So 3w times w, or even better, 3w squared. Now you see your quadratic forming. Okay, here's your quadratic. Now part 3 says solve the equation for the width of the playground, and then use part 1 to find the length, because we know the length is 3 times the width. So let's solve this. Right here, we know the area of the playground, we're given it, it's 75. So my area is 75, and that equals 3 times w squared. Solve for w squared. I'm going to use the square root method. I'm going to divide both sides by 3. 75 divided by 3 is 25, and that's w squared. And now I'm going to square root both sides, and when you square root both sides, you get a plus or minus solution. This gives me plus or minus 5. Now I get to throw out the minus 5 because width is not going to be negative. So plus 5 is my width. Now I can come up here and use part 1 to get my length. My length is 3 times my w. So length equals 3 times 5. And my length is going to be 15. And that all is in yards. And I like you to rate your units. So the width is 5 yards. Please rate your units. That's good practice. Okay, number 8 asks us, how can you verify the zeros of the function, here's your function, by using a graph? So basically that's just asking us this. Like on number 6, we were asked to use the graph of a related function to find the solutions of this equation when that equation is equal to 0. Okay, how can we verify the zeros? Basically, we would like to know when y equals 0. So we can do that when y equals to 0. We can do that by finding where this graph crosses the x-axis. Where it crosses the x-axis is where y equals to 0. So look for where the function crosses the x-axis. That's where y would be 0. Okay, number 9 asks, what are the solutions of this equation? Now, looking at this equation, we know we have graphing, and we've also solved by factoring. I'm going to guess that this one is a factor. Let's see if we can factor this guy. Factoring uses the property of the zero product property, which means if A times B equals 0, then either A was 0 or B was 0. When we factor, we do something times something else equals 0. So either that is 0 or that is 0, and that's our zero product property. Let's see if this factors. Your first term goes here and here. Your last term goes here and here, the factors of it. So we need to figure out the factors of 10 that would add up to be 7. Well, 10 is 10 times 1, or 2 times 5. 2 and 5 are going to add up to be 7. 2 plus 5 does make 7, and we want negative 7. Sorry about that. We want negative 7, and we know a negative times a negative does make a positive 10, and a negative plus a negative does make a negative 7. So we're going to go negative 2, negative 5. You can double check that by foiling it out and make sure you get back to this. And so now I know my solutions. I want this or this to be 0. What would make this 0? That's a z, by the way. They look like 2's. This is a z, that's a 2. What would make this 0 is if z were 2. If z were 2, this value would be 0. So there's one solution. What would make this value 0? If z were 5. And there's my solutions. All right, looking at this one, what are the solutions of this equation? If we solve this guy by factoring, it's always a little harder when there's a number there, but also be careful of this. This is not on the right side of the equation. We need to set this equal to 0 to solve, to figure out where our values are 0. So let's go ahead and add 12 to both sides, and that will fix that. All right, so we're going to go 3s squared minus 13s plus 12 equals to 0. Now, some of you may have learned this method where you take this middle term and you break it up by multiplying this by this, and then you figure out the terms in order to break this up, and then you factor by grouping. I am not a fan of that method. I like the guess and check method. This is what I do. I know the factors of this term go here and here, and I know the factors of this term go here and here. The only factors of 3 are 3 and 1, so I'm just going to go 3s and s. Those are my only choices. I could flip these around, but those are my only choices. There are some choices for 12. 12 could be 1 and 12. They could be 2 and 6, 3 and 4. Okay, so which one of these am I going to pick? Well, I'm going to guess and check. I know I need my inner term and my outer terms to add up to be negative 13s. That's what I need. So I'm going to look at this and I'm going to multiply these together. I need a number, and these together to give me a number that add up to be 13. I'm going to guess 12 is not going to do it because 12 and 3 is going to make too big of a number. 2 and 6 maybe. 6 times 3 is 18, and then these two are 2. If I put a 6 here and a 2 here, that's not going to give me 13. I'm going to go with 3 and 4. Now, which place do I put it? 3 here and 4 here, or 4 here and 3 here? Sometimes I just put them there and see if it works. If I put, let's see, if I put a 4, I'm guessing here. If I put a 4 here and a 3 here, okay, let's see what I get. Multiply these together, I get 4s. Multiply these together, I get 9s. Do 9 and 4 make 13? They do, but they make positive 13, and that's negative. Well, I'm going to go back and say, what makes 12? 2 negatives make a 12. Negative, negative. So let's make these both negative. They still multiply to give me 12. Now I've got negative 4s. Multiply these, I got negative 9s. That makes negative 13s. I've solved it by guessing and checking, and I didn't have to group and factor and do all the crazy stuff. I just went and solved it logically. This goes here and here. The factors of this go here and here. The inner term and the outer term have to add to be that. So you can do the guess and check method if that works for you. I've solved this and set it equal to 0, okay? So I want to know the values for s that would make this 0 or this 0. Now this one's easy, and I'm going to do this in blue or purple. What makes this 0 if s were 3? If this were 3, 3 minus 3 is 0, and that would be a solution. So s equals to 3. Now what makes this 0? A little harder. If this were 4 thirds, the 3's would cancel, and 4 minus 4 is 0. So I know if this was 4 thirds. Now if that's too tricky, just do this. 3s minus 4, this value has to be 0, and solve for s. Add 4 to both sides. You get 3s equals 4, divide by 3, and you're going to get s is 4 thirds. Okay, so if you can't see it right away, do the longer way of solving. So there are your 2 solutions to that equation. Okay, Tricia is planning an expansion of a square flower garden in a city park. If each side of the original garden is increased by 9, the total area of the garden will be 144. We want to find the length of each side. Well, let's go ahead and do this. Let me scroll this down. If I can get a square garden. If I'm just looking at a square garden and I know this is what I want. I want my area to be 144 and I want to make this bigger. Let's say I have an exact area I need it to be to grow a certain amount of fruits and vegetables. Let's say I don't know what I had, but if I increased each by 9, let's see what that gives us. X plus 9 on each side. That's what they said. The new garden will be 144. Find the length of the original size of your garden. So I'm going to do this. I know area is side times side, so x plus 9 times x plus 9. And that's going to equal my area, 144. Side times side, or length times width. Now I can solve this for x by using quadratics. First I got to FOIL this guy. First terms, x squared, and this is a perfect square, so if you know how to do 2 times a times b, you can be done with this faster, but this times this is x squared, this times this is 9x, this times this is 9x, and then the last terms is 81, and that equals 144. Now, I need to get everything on one side and simplify, so I'm going to go x squared plus 18x plus 81. And now I want to move 144 to this side. So I'm going to subtract 144 to both sides. Right? And by doing that, that's 0. So now I have to do 81 minus 144. What is that? And 81 minus 144, that is negative 63. So what I'm going to get is x squared plus 18x minus 63 is 0. Now let's see if I can factor. That would be super awesome if this factored. And let me move this over so I'm not in my face space. Okay, that didn't help. No. This is equal to 0. All right, so let's go ahead and factor this. The first term goes here and here. Now we need to figure out the factors of negative 63 that add up to be 18. Well, I know 63. What are there other factors besides 7 and 9? Let's see, 7 times 9. 7 and 9 aren't going to give us 18. Let's see what else will. 63 is divisible by 3. So let's see, 63 is going to be 3 times 21. And that is going to give us 18. If one were negative and one were positive, and that's what we need for negative 63 to happen. All right, one's going to be negative, one's going to be positive. If we want positive 18, we want negative 3 plus 21. And that's what we'll do, negative 3 plus 21. We want this to be equal to 0. So x is going to be 3, and x is going to be negative 21. Well, the x was the length of my square garden. It's not going to be negative. Cross that one out. Here's your solution. So my original garden had a length. Let's do length of 3 meters, and you're done. Okay, to find the c value to make this a perfect square trinomial, and we do this so we can complete the square. To make this, we take our b term, as long as there's not a term here, we would have to get rid of that, but we take our middle term and we divide it by 2, and then we square it. So 18 divided by 2 is 9. 9 squared is 81. So our value of c would be 81. All right, we want to solve this guy by completing the square round to the nearest hundredth if necessary. Let's go ahead and solve this by completing the square. Now, if 20 doesn't give us a perfect square, our perfect square would be the middle term, which would be negative 1. We divide that by 2 and we square it. So negative 1 divided by 2 is negative 1/2. And if I square negative 1/2, I'm going to get positive 1/4. And that is not the value here. So I'm going to complete the square here, x squared minus x. The value I need here is the middle term divided by 2. And then I square it. I'm going to add 1/4 here. And then on this side, because I added 1/4 to this side, I also have to add 1/4 to the other side of the equation to keep in balance. I can't just randomly add things when I feel like it. I got to keep in balance. All right. And then if I factor this, this is going to be x. And because this is minus, I'm going to have a minus. and it's whatever the half of this is, which was 1/2, and I square that. Just make sure 1/2 squared is 1/4. It is. And then I have 20 plus 1/4, or 20.25 if we want to go with decimals, all right? Now to solve this guy, I square root both sides. And when you square root both sides, you do get a plus or minus solution. So this is going to be x minus 1/2. And that is going, and I put parentheses, is going to equal plus or minus. Now I'm going to go ahead and do this on my calculator. The square root of 20.25, and I'm going to get 4.5. Now if we turn this to a decimal, since that's a point. Since this is a decimal, let's turn this to a decimal. X minus 0.5 equals plus or minus 4.5. Now I'm going to add 0.5 to both sides. Now I have two solutions here, so I need to add it to both solutions. This is going to be x equals positive 4.5 plus 0.5. If I do positive 4.5 and I add 0.5, I'm going to get 5. Negative 4.5 plus 5 is going to give me negative 4. So there are my two solutions when I completed the square, 5 and negative 4. Now because I came out with whole number solutions like this guy does factor. If I move this to the other side real quick, x squared minus x, if I move the 20 to the other side, minus 20 equals 0, whole numbers are going to factor. This is going to be x and x. The factors of negative 20 would be, and to give me a negative 1, so I'm going to do negative 5 plus 4. And the solution here would give me negative 4 and positive 5. So factoring would have been quicker. All right, use quadratic formula to solve this guy, round to the nearest hundredth if necessary. So quadratic formula, I'm going to write it up here. Negative b plus or minus the square root of b squared minus 4ac all over 2a. If you've ever heard this, a negative boy couldn't decide whether to go to a radical party. Being square, he decided not to go. And he missed out on 4 awesome chicks. The party wasn't over until 2 a.m. I don't know. It's something to help you remember. So look at this guy. And if we want this quadratic formula to work, everything has to be on one side of the equation. We got to move 9x over there. So x squared, subtract 9x to both sides, minus 9x plus 16. And since I subtracted this to this side, I get 0 on this side. Now you can do it. Here's my b value, my a value, my c value. So negative b would be negative 9, which makes positive 9, plus or minus the square root of b squared, negative 9 squared, minus 4 times my a value, which is 1, times my c value, which is 16, all over 2 times my a value, which is 1, and I'm not going to write that. Now simplify here. So I'm going to write under the radical this part. 9 squared is 81. Negative 4 times 1 times 16. Let's go 16 times 4, and it gives me 64. So I'm going to go 81 minus 64. This is the part that's under the radical. 81 minus 64 is 17. If this part under the radical was negative, I would have imaginary numbers. So 17 is under the radical. I simplified that. So I'm going to get 9 plus or minus radical 17 divided by 2. Now, I can simplify the 2 if the 2 divides into this term and this term, but it doesn't. So, remember, you have to distribute, and there's your final answer. Real quick, if it asks you to round to the nearest hundredth on the test, just plug in radical 17 on your calculator, and then you're going to go 9 plus that, and you're going to divide that by 2, and you're going to get 6.56, and if you do 9 minus radical 17 divided by 2, you're going to get 2.44. So both of these values are also correct. You can do both of these. Okay, let's look at 15. A model rocket is launched from a roof into a large field. Cool. The path of the rocket can be modeled by this equation, where x is the horizontal distance in meters. So let's take a look at what that might look like. If we had some kind of XY axis, and the model rocket's launched from a roof into a large field. So let's just say here is some kind of building, and here's the roof of the building. So if we launch it from the roof into a large field, something like this, and it's going to land, okay? It's modeled by this equation where x is the horizontal distance in meters from the starting point on the roof and y is the height. So this is the height and this will be the horizontal distance in meters starting from the roof. Okay, so from here to here. How far horizontally from its starting point will the rocket land? So we want to know this point here. Now if this was a full parabola, it would have some negative points too, here, and then a positive point here on the x-axis. It would have 2 points. But since we're starting from the roof, we're shooting up and down, we're really only looking for this positive solution. That's how far horizontally from its starting point it would land. We don't care about this back part of the parabola. So if we take this, really, we just need to solve this and figure out its solutions or its zeros. Where does it touch the x-axis, or where is y 0? Now looking at this equation, it's not going to factor super easy. Look at those values. So I would use quadratic formula. So let's go ahead and do that. Remember, quadratic formula is negative b plus or minus square root of b squared minus 4ac all over 2a. So let's plug in our point or our values. Here's a, and let's undo that. Here's our a value, here's our b value, and here's our c value. So if we do negative b, and I wrote on top of that, sorry. If we do negative b, we're going to do negative 7.5 plus or minus the square root of b squared, so 7.5 squared, minus 4 times a, and our a value is, oh, that's ugly, minus 4 times a, which is negative 0.4, and that's a 0.4 times c, which is 10.2, and I'm running into my chart here. All right, all over 2 times a, which is negative 0.04. And I said 0.4. Sorry about that. Okay, now we're just going to calculate these values. This is just a matter of calculation, so grab your calculator and make sure you work this out correctly. And I'll do that real quick. So if you work this part out under the radical, 7.5 squared is 56.25, and then negative 4 times negative 0.04 times 10.2, all of this, it is a positive value, and this whole thing becomes 57.882. So this will be, I'm going to write it down here, negative 7.5 plus or minus the square root of 57.882 all over 2 times .04, which is negative 0.08. And now go ahead and just do the math on this. Use a calculator, find the square root of that whole blob, add it to negative 7.5, and then do negative 7.5 and subtract it, and find your two values. Okay, so I put this in on the calculator. Negative 7.5 minus this divided by this is going to give you 188.89 or 0.9. And if you do negative 7.5 plus this divided by this, you're going to get negative 1.35. So if you can look on our graph here, negative 1.35 would be this point, and negative 189.9 would be this point. Now we're not going to care about this point because we want to know from here, where does it land? And it would land here. So that tells us how far horizontally from its starting point will the rocket land. So where should we look for the rocket? That's what we want to know. This will tell us. So math can actually help you find your toys. Look at that. All right, so 188.9 or 89 meters. All right. Let's go ahead and pause. Okay, the great thing about this question, it doesn't actually ask you to solve. It just says how many real number solutions does this equation have? So we want to know if it's real or if it's imaginary. Now we know the square root of any negative number is an imaginary number, is I. All right, so anything that is square rooted that's negative is imaginary. Now the beauty of imaginary numbers is when we square them, Square root of -1 squared is I squared, right? Well, square root of -1 squared, the square and the square root cancel, you just get -1. So I squared is beautiful because it's a real number, but I is an imaginary number. So just a little tidbit on that. We're looking for how many real number solutions. Now, knowing what we know about the quadratic formula, I'm writing it again here, just a second, all over 2a. So we have -b plus or minus square root of b squared minus 4ac all over 2a. Now we know this part here is what will tell us if we have an imaginary or a real number, because it's the part under the square root. If this value under the root is positive, I know I have a real number. If this value under the root is negative, I know the square root of a negative number is an imaginary number. So we just check this part. We just check b squared minus 4ac. Now we want to know how many real number solutions. We need this to be positive, not 0. We want it to be positive. And if it was 0, if this value was 0, we would have one solution specifically, because we wouldn't have plus or minus anything. It would be plus or minus 0. So we're going to include 0. We're going to say this part has to be greater than or equal to 0 because one solution is still a real solution. All right? So we got b squared minus 4ac, and let's go ahead and do this. Let's go b squared, so we're going to go 4 squared, which is 16, minus 4 times a, which is -2, times c, which is -2. Now, is this greater than or equal to 0? Well, let's see. 16, and then we're going to go negative times a negative is a positive, so this becomes positive 8 times -2, which becomes -16, and this becomes 0. So if this value is 0, I have -b plus or minus nothing over 2a, or just -b over 2a, which gives me just one solution. I'm not doing plus or minus something, I just have one solution. So how many real number solutions does this have? One solution. All right. All right, we're going to graph this set of points. Which model is most appropriate for this set? Well, let's graph it and see what we got. Let me see. We're going to go -0.5, 0.5. So just this little point right there. Over 1, up 1, 2, 3. There's a point. We're going to go 1.5, up 4.5 here. Then we're going to go over 2, up 5. Then we're going to go over 2.5, up 4.5. Let's see, right here. And we're going to go over 3.5, up 0.5. All right, looking at this, it looks like it goes up and comes back down. Even though it doesn't have this point right here, this looks pretty quadratic. It looks like a parabola to me. So I'm going to say quadratic. If it were exponential, it would look something like this. If it was a line, it would look something like this. It doesn't look like either of those. It looks like a parabola to me. Okay, looking at this guy, which kind of function best models the data in the table? Use differences or ratios? So if you look at your x value, they each increase by 1. Perfect. When that happens, you don't have to do the ratio of each of these. You just have to check your differences or ratios here. So we can first go and check and see if the differences are going to be constant. So let's go. To get from -3.4 to 6.8, to get from here to here, I'm going to subtract 3.4. Now to get from 6.8 to 13.6, I'm going to subtract 6.8. So it's definitely not constant. Now we can check the second differences to see if we have quadratic, or let's check our ratios first before we get to that point. So let's go from here to here. To check our ratios, you take your second and divide it by your first. So -6.8 and divide it by 3.4, and you're going to get a ratio of 2. So let's do this. Let's do a ratio. This will give me a ratio of 2. If we do 13.6 divided by 6.8, they're both negative, I'm going to get 2. Oh, that's looking good. Let's see what happens when I do 27.2 and divide it by 13.6. I'm going to get 2, and then 54 divided by 27, I'm going to get 2. So this has a common ratio. The ratio you get by taking the second term, dividing by the first term, and we did this back in Math 1, if you'll recall. When you have a common ratio, you have an exponential function, okay? Exponential. We called this a geometric sequence. Remember when we studied arithmetic or arithmetic sequences and geometric sequences? So this would be an exponential function. Okay, let's check this guy. The table shows the estimated number of deer living in a forest over a 5-year period. So we are checking deforestation. Are the deer population, is it going down? Is it going up? What's the hunting season like? Which type of function best models the data? Write an equation to model the data. So we don't just want to know the function. This time it asks you to write an equation, so don't skip that part. It asks you 2 things, okay? So once again, we're going to check and see if we have a linear y equals mx plus b. That would be a linear. This would be a common difference, okay? A common ratio would be for your exponential. Y equals a, some number, times b to the x. That's your exponential. That would be a common ratio. Now a second common difference would be your quadratic. Y equals ax squared. And if you want the whole thing, plus bx plus c, or just your basic y equals ax squared if it doesn't shift, okay? So let's check and see what we have here. Let's check our differences first, because linears are easiest, right? If I go 93 and subtract off 58, to get from here to here, I would minus 35. To get from 58 to 36, I minus 22. So I already know it's not going to be linear because there's not a common difference just in the first 2. Now I could keep checking to see if it has a common second difference, but before I do that, let's check ratios. Let's check the ratio of 58 divided by 93. All right, to get from here to here, I'm going to multiply with a ratio of 0.62 about. Let's do these 2. Always take the second one and divide by the first one. This is going to give me 0.62. Take the second one, divide by the first one. 22 divided by 36. This is looking good. I get approximately 0.61, which is close. And then 14 divided by 22 gives me 0.63. So I'm going to say, yes, this is going to have a common ratio of approximately 0.62. Now, a common mistake is to take 93 and divide it by 58. That gives you a common ratio of 1.6. Remember, you're telling me how to get from here to here, not how to get from here to here. Okay, so be careful of that. So I'm going to say, yes, it has a common ratio. All right. So we would say this is a geometric sequence, and a basic equation for an exponential is going to be y equals some value times your base raised to the x power. Okay, y equals a times b to the x. A is always your initial value. The reason it's your initial value is because if I plug in 0 for x, anything to the 0 power is equal to 1. Okay. Anything to the 0 power is 1. So if I plug in 0 for x, for my initial value, 0. If I plug in 0, this becomes 1, and I just have a times 1, or just a. Okay, so y equals to a. So when I plug in 0 for x, I always just get y equals to a. So a is my initial value. Whenever I plug in 0, I just get out a. So here, my 0 for x gives me out 93. So my initial value is 93. Okay. A in your exponential is always your initial value. Right. So I know A is 93. My base is my common ratio. This is what I'm going to start with 93, and then I'm going to multiply it by 0.62 however many times I do it. And this is what this tells me. So I'm going to take my initial value of 93 and I'm going to multiply it by 0.62 to the x power. That means how many times do I do it? So 0, the first term, I do it 0 times, this becomes 1, and I just get 93. I do it 1 time, I plug in 1 here. I'm going to take 93 and times it by 0.62. So when I do it the first time, I take 93 and times it by 0.62 and I get 58. That's how I get my first, or it's actually my second term, but when I plug in 1. I plug in 2, I take 93 and I multiply it by 0.62 2 times, here to here. So that's how your exponential works. Okay, so remember, this is the formula for an exponential equation, and if it asks you to write an exponential, make sure you know a linear too, if it happens to be a linear, and make sure you know the quadratics, which is what we've been working on this whole time. All right, so with the exponential, a is your initial value, always your 0, and then b is your common ratio, and then you take it to the x power. Y equals 93 times 0.62 to the x. All right, this one wants you to solve this system. So you have, looks like a parabola and a line, and they want you to solve by graphing. Now this would be pretty easy to solve by substitution. Honestly, that's how I would do it, because I plug in 3 for y and then solve this, but it asks us to solve by graphing, so let's make sure we do that. So what I'm going to do is, first I'm going to graph this, y equals to 3, that's the easy part. So I go where y is 3, 1, 2, 3, right here. Y is always 3, doesn't matter what x is, y is always 3. So there we have it. All right. Now to graph this, I need to find my vertex, so I'm going to go negative b over 2a, and then get my y value. So my b value is 2, so I go negative 2 over 2 times my a value. My a value is here, nothing's written there, it's a negative 1. So negative 2 divided by 2 times negative 1 is negative 2. Negative 2 divided by negative 2 is 1. All right, there's the x value of my vertex. Find the y value, plug in 1 here. So I'm going to go negative, and then negative's on the outside, so I'm going to go 1 squared. Careful, this is often a mistake. People think this negative is squared, but it's not unless there is a parentheses here. Okay, negative 1 squared plus 2 times 1, which is just 2, plus 2. So 2 plus 2 is 4, and then 1 squared is just 1, and multiply it by a negative, it's negative 1 plus 4, which gives me 3. So negative, 1, I go over 1, up 1, 2, 3. Oh, there it is. I found my solution. That's going to be my solution. I know it's negative, so my parabola is going to open down, and I don't even need to find any more points. I already found where it touches y. So my solution is going to be right here, this point. This is where these two intersect, is going to be right there at that point at my vertex. So the point 1, 1, 2, 3. 1 for x, 3 for y. Excuse me. And you're done. Easy peasy. All right, let's look at this one. Use substitution method to find the point or points where the parabola and line intersect. So we have a parabola and a line. This time we're going to use the substitution method. So that means we're going to substitute this value in for y in this value. We know y equals this. Take this value and substitute it in for y here and solve algebraically. So we're going to go x plus 3. Oh, it's being slow. X plus 3. Yeah, hold on. All right, so plugging in here, x plus 3 equals x squared plus 6x, and it's not working, plus 7. What is the deal? All right, we're going to try this again because that wasn't working. Plug this in. We're going to get x plus 3 equals x squared plus 6x plus 7, and solve this algebraically. So subtract x to both sides. That eliminates that. Subtract 3 to both sides at the same time. So on this side, I'm going to get 0 equals x squared, and then 6x minus x is 5x, and then 7 minus 3. All right. So now we have this set equal to 0. Now it would be great if this factored. Let's see if it factors easily. This term would go here and here, and the factors of 4 would go here and here. Now we know the factors of 4 would be 1 and 4 or 2 and 2. We want them to add up to be 5, so of course I'm going to pick 1 and 4, right? Inner terms and outer terms, well, inner term will be 1x, outer term will be 4x. They do add to be 5x. Plus and plus, it works. So zero product property, what makes this 0? If x were -1. So x equals -1 would be one solution. What would make this 0 if x were -4? So -4 and -1 would be the solutions that would make this work, okay? Once we have that, we need to find our y points. So we want to find the points where the lines intersect. All right, so we found our x points. -1 and -4 are x points. We need our y points. So to get that, we plug in 1 for x. And let's do that over here. We're going to get y equals, I plug in, -1 for x. -1 plus 3 is going to give me y equals to 2. So when I plug in 1 for x, I'm going to get out my y value of 2. Now let's plug in -4 for x. You could plug it in here too, but it'd take more work. This is easier. So y is going to equal -4 plus 3 or -1. And there we have it, -1. So my y points are these, my x points are these. Now tell me what the actual xy value is. So I'd like to see this. My points are going to be -1, 2 and -4, -1. Here are my points, and this would be my solution. -1 and 2 is where these two intersect, and -4, -1 is where these intersect. You can always check this on a grapher. See if it's where these intersect. Let's go ahead and check it on Desmos real quick. I'm going to plug these two values in on Desmos and see if it works. Okay, I'm going to plug these two into Desmos, and I typed them in, x squared plus 6x plus 7 and y equals x plus 3. Here's my parabola, here's my line. Here's where they intersect at the point -1, 2, which is one of our points, and at the point -4, -1. So we've done it correctly, and you can check that on Desmos. All right, on to 22. Okay, for 22, we're checking the discriminant again. What's the formula for the discriminant? Well, it's the under the square root part of the quadratic formula, b squared minus 4ac. So that's part 1. Part 2, what inequality would you use to show there are two imaginary solutions? Well, in order for it to be imaginary, this is the part under the square root of the quadratic equation. So what would make this an imaginary is if the value under the square root were negative. So the formula, or the inequality, would be b squared minus 4ac. That would mean this has to be less than 0. Not equal to 0, just less than 0. All right? We're going to use the inequality in part 2 to find the value of g so that this equation has two imaginary solutions. Okay, so we want b squared minus 4ac to be less than 0. So let's figure that out. Look at our equation here. My a value is 2. My b value, nothing's written there, so it's a 1. So my b value is -1. And then my c value, I don't know, it's g. We got to figure out what g is. But I know a is 2, b is -1, and c is g. It's that. We need to figure out what that would be so that this is less than 0. So I plug it in. I'm going to go b squared minus 4ac. B squared minus 4ac. I want that to be less than 0. So my b value is -1. I'm going to square that. Minus 4 times my a value, which is 2, times my c value, which is g. So I'm going to solve for g. Now you got to figure out what value of g would make this less than 0. So let's do it. -1 squared is 1. -4 times 2 is -8 times g is g. So this becomes -8g. That has to be less than 0. Solve. -1 to both sides of the inequality. -8g is less than -1. Now I just subtracted. I didn't divide by a negative, but now I am going to divide by a negative. Careful, when you divide by a negative, red flag should go off. This has to flip. this becomes G is greater than, and negative divided by a negative is a positive. G is greater than 1/8, and you're finished. So in order for this to have two imaginary solutions, your G value has to be greater than 1/8. That's going to force this to be less than 0, which would cause you to have imaginary solutions. Okay, now this next one is a little tedious and long, and I posted a video to try to help you with solving equations with 3 variables because it is tedious. So let's go ahead and look through this. Okay. What is the equation in standard form of the parabola that contains these 3 points? Now, this means you have to solve 3 equations with 3 variables with systems of equations. We're actually going to do this again in Math 3, but for now, I showed you a quick way to do it. So here's what I want. I know an equation for a parabola in a standard form looks like this. Y equals ax squared plus bx plus c. So I've got an x, a y, an x, a y, and an x and a y. So I'm going to have 3 equations. My first equation will look like this. My y value will be negative 17 equals a times my x value, negative 2 squared, plus b times my x value of negative 2 plus c. So I have to figure out what a, b, and c are. Now my second equation is going to look like this. My y value of negative 3, and then a times my x value, which is 0, so this a is going to go away, plus b times my x value, which is 0, b will go away, plus c. So my second equation will be negative 3 equals c. Yay, that's awesome. And then my third equation will be negative 23 equals a times 4 is my x value. I square that, plus b times 4 plus c. All right, so let's simplify these a bit. And we're going to go ahead and get, and I'm just going to erase this because I am going to run out of room. So I'm going to erase this, and it's going to become negative 2 squared will become 4. So this is 4a or a4. Let's write it as 4a because a4 looks weird. 4a, and this is negative 2b. I'm going to rewrite that so I don't run out of room, negative 2b. And then this, negative 3, a times 0 plus b times 0 plus c, this just becomes just negative 3 equals c. And then this part, 4 squared is 16, so I'm going to write this as 16a. And then instead of 4b, I'm going to write b4, I'm going to write 4b. 4b. All right, so here's my 3 equations and 3 variables. Now, one thing that you can do is to simplify would be gather 2 equations, find a system of equations to eliminate one of the variables, and then another 2 equations and eliminate that same variable, and then you'll be left with 2 equations, 2 variables. But this one is even easier, and the reason is, if you look here, we have negative 3 is c. So by plugging in negative 3 into both of our equations, and let's use a different color, we can plug in negative 3 here for c and negative 3 here for c. By doing that, I'm left with 2 equations, equation 1 and 3, and 2 variables, a and b. So let's do that. Here's equation 1. I'm going to write it as negative 17 equals 4a plus negative 2b, and I know c is negative 3. Plug it in. And then here's equation 3. I've got negative 23 equals 16a plus 4b, and then we know c is negative 3. Yay! That simplified it. I didn't have to go eliminate A in this one and then get these two equations and eliminate A and then just be left with B and C. I didn't have to do that. They gave me C. So now look, I have equation 1 and 3 and I have 2 variables and 2 equations. Well, I can solve 2 equations with 2 variables. Let's get the A's to fall out. I can do that by multiplying this equation through by -4. If this were -16 and this were +16 and I added them together, the A's would fall out. So I'm going to multiply both sides of the equation by -4. Okay, so let's multiply this by -4 and let's multiply this by -4. Okay, both sides of the equation. So new equation 1 I'm going to write down here. And let's go, what's 17 times 4 is 68. Equals, this becomes -16a. So I do -4 times this, -4 times this. This becomes plus 8b. That's an 8. And then -4 times -3 becomes positive 12. Now I'm going to add these 2 equations together. And if I do 68 and I subtract 23, I get 45. And then the A's fall out, which is what I wanted. 8 and 4, 12b, and then 12 and 3 gives me 9. So now finish this off by adding 9 to the, or excuse me, subtracting 9 to this side, 45 minus 9. And then go ahead and divide by 12. So I'm going to get 36 on this side equals 12b. And divide by 12. And I'm going to get b is, and then we're going to go ahead and do solving for a. So I found b. I already know c right here. Now to get A, I can plug in B and C into either equation 1 or equation 3 to figure out A. So let's use equation 1. We're going to go -17 equals 4A. We're trying to figure out what A is. We know what B is. B is 3. So I plug in 3 here for B and -3 for C because I know C is -3. I know B is 3. So when I plug in 3 for B, I get -6, and when I plug in -3 for C, I get -3. Now I can solve for A. -6 minus 3 is -9, so I'm going to go -17 equals 4A minus 9. Add 9 to both sides. Let's do -8 equals 4A, and then divide by 4. That was a 4. And I'm going to get 8 is -2. And I have my B, my A, and my C. Now I can write an equation in standard form with these 3 points here. And it looks like this. Y equals, my A value is -2 x squared. My B value is 3. And my C value is -3. And there is my equation. And that is a ton of work. I know. 3 equations and 3 variables is quite the trump to work out. Okay. All right, after doing number 23, we need something simple. And let's do this. We need to simplify the number using the imaginary unit I. Remember, square root of -1 is the imaginary unit. It is I. Just a real quick on that. Why is this an imaginary number? That is because the square root undoes the square. So let's take the number 2, for example. If we square 2, we get 4. And to undo that, we square root 4, we get back to 2. Yay. If I take -2, I get 4. When I square a negative, I get a positive. So square root 4, you get back to 2. The square root undoes the square. So when I square a negative number, I get a positive number. When I square a positive number, I get a positive number. So how can I undo a square if this is negative? What do I square to make a negative in here? What got squared to give me -1? It's weird. An imaginary number did. But the square root of negative 1, if I square that guy, the square and the square root cancel, I get negative 1. So the beauty of this is if I square I get negative 1. So I squared gives me a real number. The square root of negative 1 is not a real number because when I square something, it becomes positive. Always. And so I should square root always positive numbers. I should never be square rooting a negative number. It's not real. So that's our imaginary guy, and the reason we use it is because when we square it, I get a real number. So if I'm going to square root negative 36, just remember anytime there's a negative inside, you could separate it like this. The square root of negative 1 is I. The square root of 36 is 6, so you get 6i. And you're done. Simplify this expression. This is just FOILing. Treat I like any other variable, treat it like an x. Just remember I squared does give you negative 1, okay? Because the square root of negative 1 is I, and the square root of negative 1 squared is negative 1. That's your I squared, okay? So remember that. FOIL this out. 6 times 1 is 6. 6, so that's your first terms, your outers. 6 times 3i's plus 18i. Negative 4 times 1 is, negative 4i times 1 is negative 4i. Negative 4 times negative 4i times 3i is negative 12i squared. I squared is our friend, that's negative 1. So let's simplify this. We get 6. Treat the i's like variables, like x's. 18 minus 4 gives me 14i. And then negative 12i squared. Well, I squared is negative 1. So negative 12 times negative 1 is positive 12. And this is simplified. I lost my problem. What did I have here? 6 plus 14i. And then we had plus 12. All right, now this is almost simplified. 6 plus 12 is 18 plus 14i. And there you have your most simplified solution. And you're done. All right, we're going to use quadratic equation to find the solutions to this guy. Quadratic equation, negative b plus or minus square root of b squared minus 4ac all over 2a. That says a and that should say c. Sorry about that. This pen is not very useful. Okay, here's my a value, my b value, my c value. You just plug in your values and you run with it. So negative b, negative negative makes positive 2. Plus or minus square root of b squared, so negative 2 squared, minus 4 times your a value, which is 0.5 or 1/2, times your c value, which is 3, all over 2 times your a value, which is 0.5. Go ahead and do the math on this. Calculate this with a calculator. If we do negative 2 squared, you get 4. And I'm going to write this over here because you don't need to sit and watch me do these calculations. So I lost you for a second. All right, negative 2 squared is 4. Multiply this out. Half of 4 is 2. 2 times 3 is 6. So this is going to be minus 6. So this will be the square root of 4 minus 6, this part. 4 minus 6 is negative 2. So this whole thing becomes negative 2. So this is going to be, I'm going to write it down here, 2 plus or minus the square root of negative 2 over half of 2 is 1. So this is just 2 plus or minus the square root of negative 2. Now you know you can simplify this to 2 plus or minus the square root of negative 1 is I. So this is going to be I times the square root of 2. And that will be your final solution. 2 plus I square root of 2 and 2 minus I square root of 2. Okay, looking at the parabolas in this last section in your text, you look at parabolas in vertex form, and you also look at it with the focus and the directrix, okay? And that's really how a parabola is defined. If you think of like a satellite dish, and you have like some kind of center point, and directrix is the line on the other side. So your parabola is the set of all points that are equidistant from the focus and the directrix. So every point on this parabola would be equally distant from here and this line, okay? From here to here, here to here, here to here, here to here. That is how you define the parabola specifically. And if you want to put it in vertex form, y equals a x minus h squared plus k. And your hk is your vertex. So you just take your basic y equals a times x squared, and to shift it to the vertex, you would go x minus the h value, or the x value of your vertex, and then your k value is on the outside. So this is your parabola in vertex form. The focus and the directrix help us find the equation for the parabola. So let's remember a equals 1 over 4c. So if we're looking for our a value is in front of our x squared. And our c value is going to tell us our focus, okay? So y equals something times x squared is going to be a happy face or a sad face parabola. I know it's a sad face parabola because the a value is negative. So I know it's, if it was x equals y squared, I would know I'm a side-to-side parabola, okay? So I'm looking at this, I know it's an up and down parabola because it's y equals x squared, and I know it's a sad face because it's negative. So my focus will be on this side, and my directrix will be on this side, okay? So it asked me for the focus and the directrix, and I know my a value is equal to 1 over 4c. Here's my a value. So negative 1/8 equals 1 over 4c. And I can figure out c just by solving. All right. If you want to cross multiply, you can do that. 4c times negative 1. If I just cross it, it's negative 4c. And then 8 times 1 is 8. Solve for c, divide by negative 4. And you're going to get c is equal to negative 2. So I know my c value is equal to negative 2. So from my center, I'm going to go in the negative direction. So I know this is at 0, 0 because it doesn't shift. It's not x minus h plus k. It's just at 0, 0. And I didn't draw that very good, right? So I know my focus is in this direction because it's a sad face parabola. So it goes 2 in this direction, 1, 2. Here's my focus, 2 in the negative direction. So this point would be the point 0, negative 2. Here's my focus. My directrix is going to go from here opposite, 1, 2. And this, because it is a horizontal line, this will be y equals to positive 2. So there's your directrix and there's your focus. So remember, your focus is always on the inside of the parabola. The directrix is the same distance on the other side, and it's a line. Okay, so figure out which way your parabola points, and that will tell you, once you find your c value, which direction from your vertex you go. 2 this way. We went 2 in the negative direction. And there you have it, folks. Okay, let's look at one more of the parabolas with vertex form. All right, remember just real quick, vertex form is y equals a, instead of just ax squared, if you shift off of the 0, 0, for your vertex, it would be x minus h squared plus k. Now, if you multiplied this out, you would get the y equals ax squared plus bx plus c. But the vertex form is great because it tells us h comma k is your vertex. Now, that is if you have a happy face, sad face parabola, your standard function parabola. You could also have a parabola side to side, and that one would be the x equals a times y minus k squared plus h. So this one is a little different. It's the y squared parabola. Now, how do you know which one you have? Well, look at your vertex and focus. So if we have a little graph here, let's look at what we have. Our vertex is negative 2, negative 1. Here's our vertex right here. Our focus is negative 2 up 2. If this is our vertex and this is our focus, we know our focus is inside our little parabola. So I'm just sketching something here. This isn't necessarily what it looks like. It has to look something like this, where this is my focus, and I know my directrix is that same distance on the other side. So if this is up 1, 2, 3, this is going to be back 1, 2, 3. My directrix will be down here. Now this is great because the distance from my vertex to my focus, that distance is the value c. Okay, and I can count that 1, 2, 3. So I know c equals 2, 3. Now because I have a happy face parabola, I have this, y equals ax squared. My vertex is hk. Well, they told me that. It is -2, -1. That is my vertex. I need to know my a value, and then I can write my equation. Well, I know that a equals 1 over 4c. I was given that relationship. Great, I already know what c is. It's the distance from my vertex to my focus. It's 3. I know c is 3, so now I can figure out a. A equals 1 over 4 times 3, or a is 1/12. I have everything I need to write my equation now in vertex form. It is y equals to, my a value, I know right here, is 1/12, times x minus my h value, that's the h value of my vertex, so I go minus h is -2, so I'm going to go minus -2, which is actually +2. Minus a negative is plus, squared, then plus k. My k value is -1, so I'm going to go plus -1, or just write -1. And there is your equation in vertex form. Your vertex is -2, -1, and your a value is 1/12. Your c value is right there. All right, last two, we're almost done. Write an equation of a circle with the given center and radius. Here's your center, here's your radius. So make sure you know the equation of a circle. So the equation of a circle would be, if you are at 0, 0 for your center, it would be just x squared plus y squared equals r squared. But we are going to be off center. The center isn't going to be 0, 0, so it's going to be x minus h squared plus y minus k squared equals your radius squared, where h comma k is your center. And that's your center. So just write it here. We're just going to go x minus -8, makes it x plus 8 squared, plus y minus -6, which makes y plus 6 squared, equals your radius squared. Well, it's 6, so square it and you get 36. There's the equation of your circle with the center and the radius. It's pretty simple. You probably did that a while ago. And one more. Let's look at, write an equation for translation of x squared plus y squared equals 16 by 4 units to the left and 3 units up. So right here you can see there's no hk. It's the center of 0, 0. So just look at it. It's pretty simple, right? If you are 4 units left and 3 units up from center, here's your center. Let's go 4 units left, 1, 2, 3, 4, and 3 units up, 1, 2, 3. So now your center is -4, 3. Now just write it. You're going to go x minus 4 squared plus y, since it's 4 units left, I should have gone x minus -4, or x plus 4 squared, plus y minus 3 squared equals 16. And that would be this equation shifted 4 units left and 3 units up. So plus 4 minus 3. And there we have it, folks. That was a ton of work. I know it's a long one. If you have to separate it into 2 sittings, please do that. It's quite a few sections. Let me know if you have any questions, and have a great day.